Hi, my name is Jose Garrido, and the following presentation is a demographic comparison of semi-urban and wild populations of Kinosternon chimalhuaca, or more commonly, the Jalisco mud turtle. Turtles are the world's most endangered terrestrial vertebrate. With over 60% of species endangered, they are primarily threatened by climate change, land development, and overexploitation. To survive in urbanized and arid regions, mud turtles utilize man-made water sources such as cow troughs or irrigation ditches, but there's still little research on how these conditions affect their population structure. Discovered over 20 years ago, there have been no demographic or ecological studies published about the Jalisco mud turtle to date. Here, I will present the first population study in both a semi-urban habitat in an irrigation ditch flowing through a small town in southern Mexico, and a nearby wild habitat in the Chamela-Cuixmala Biosphere Reserve, a pristine neotropical dry forest, both seen on the bottom left. Between these two sites, I expected to find significant differences in both sex ratios and size of turtles. Turtles were captured with baited hoop nets by myself and by other members of the Sobre Mexico program in July and December of 2019. Weight, sex, and several measurements of size were taken before giving them a notch in their shell to give them an individual ID for mark and recapture studies. Some data was also taken from prior observations by other researchers from the field station. In the wild site, 36 turtles were captured, while similar effort in the irrigation ditch in town astonishingly yielded 226 turtles, estimating a population size of around 750, give or take 56. It was here that I captured the first recorded albino or hypomelanistic Jalisco mud turtle seen in the upper photograph. Between these two populations, sex ratios differed significantly. Looking at the bottom graph, the semi-urban turtles had 2 females for every male, while wild turtles were the complete opposite, with around 1 female for every 4 males. Because sex ratios are determined by temperature in the egg for turtles, these results could be due to warmer nesting temperatures in town. Now, principal component analysis found that SLC, or the length of the top of their shell, is the most reliable dimension for measuring body size. Using this measurement, a histogram of males and females from both sites is seen in the upper right. A post hoc Dunn's test showed that there are significant differences in the size of males and females between sites, as well as sexual dimorphism. Wild males also showed a narrow and bimodal distribution compared to the widespread distribution of males in town. These data support my original prediction. However, a low sample size and recapture rate for wild turtle limits the strength of the comparison. Nonetheless, these interesting findings warrant further investigation into the influence of man-made habitats on turtles, and thus I'll be conducting a thorough study of population structure, diet, thermal ecology, and movement of turtles in both habitats this summer. If you'd like to read a complete write-up of my preliminary data, please take out your phone's camera and follow the QR link on the top right. I'd like to thank Dr. Daniel Beck, Taggart Butterfield, and everybody else who made the study possible. Thank you.